welcome back to the GP Effects Academy. Today we are going to be prepping Waec Physics Practical for 2026, and the first one, as we have there, is what is mechanics. So for the apparatus, they said you are provided with the apparatus above. So these are the apparatus we asked to provide: meter rule, meter stand. These are 2 meter stand, as you can see them. We are also have to provide a thread. This is a thread. These are spiral springs of they are equal. We also have a pendulum, but we are using this in place of our plasticine. And we also have our masses here. We are told to provide masses 150 to 350 grams. This is our stopwatch, and this is the optical pin. So the next instruction says that we should set up the experiment as shown in the diagram above. So I'm going to be displaying that diagram above here of this setup. So as you can see, the experiment, that is number 2. Set up the experiment as shown in the diagram above. So this is experiment as shown in the diagram. So with the meter rule suspended, we have also done that. We have put it at equilibrium. All right, so use the optical pin as a pointer. All right, so we are going to be using our plasticine to place. We have already determined the center of gravity, which is 50. So if you look at this, what we have here is 50. That's our center of gravity. So we are going to be using our tape with our pointer here together on that point, so that it does not move, so that this does not move during the experiment. So after this, the next instruction is to attach a mass of 150 grams to the center of the meter rule. So this is 150. So we attach it to the center. You can see that there is an extension in the spring. All right. So the next thing for us to do is to take 20. Okay. So displace the meter rule slightly towards through a small distance and release it gently to set the system into vertical oscillation. So this oscillation here is 20. So I'm going to be displacing this just about 2 centimeters. All right, so I'm going to be displacing this about 2 centimeters, and we take for 20 oscillations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. So the time you have here is going to be recorded. Oh, let's do our table. All right. So because it is time taking, we have to do our time taking twice to avoid errors. So we are going to be doing 150 again. I removed this because I was not taking readings. So I'm going to be taking 20 oscillations again. Okay, here we have 9.13. Okay, so that is for 150. The next one is 200. Yes, 200. So 200. We place it at the center. Okay, then we displace again about 2 centimeters. So 1, 2, 3, 4, 5, 6, 7, 8. So here we have 9.81. Let's do it again. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 10, 13, 14, 16, 17, 14, 15, 0.28. Okay. So this is 250. Let's do it for 250 again. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So for 250 we have 10.60. Okay, let's take 250 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 10.84. Okay, so the next one is for 300. So remove this totally, remove 50 and add 100. So this is 300. So for 300, we displace it 22 centimeters. So if you look at it at this position, it's getting close to the so let's displace it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. So here we have 11.57. Let's displace it again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 11.69. Okay, so the last one, we are removing this and putting the last one. That's 350. Wow. Okay, let's take our readings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, let's do it again. Let's do for 350 again. So, okay. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have okay. So these are our values. We have gotten M, T1, T2. So the next thing is to find our mean T. Alright, so this is our readings. This is our table of values. We have our M because here they said tabulate your readings of M, T1, T2. You need to find the average, your period and T square. So this is T1, T2, the average. This is our period and T square. Alright, so they said plot a graph of T square against M. Plot a graph of T square against M. So that's what we are going to be doing, and we are going to be plotting a graph of T square on the vertical axis and M on the horizontal axis.
Okay, so at this point, my phone was no longer recording the audio, and by the time I could detect, it was already late. So I was trying to draw the axis T square and M, that's the vertical and the horizontal axis, and I was putting the scale. We are using 0.05, 2 centimeters representing 0.05 on the vertical axis, and on M we are using 2 centimeters represents 50 units on the horizontal axis. Alright, so after doing that, the next thing is to start plotting your graph from the table of values. Okay, so I was trying to explain to you how we choose our scale and all that. Okay, so we want to start plotting the graph. I'm going to write the table of values there so that you can see it. So I've started plotting the graph to scale. Okay, so okay, you're going to see the readings pretty soon. So we have about 5 readings, and I was plotting them here based on our readings from the table. Okay, that's the 4th one, and the last one is 350 to I think 0.372. Okay, so the next thing we want to do now is to draw your line of best fit. Don't forget, your line of best fit must split your points into about equal sides. That means since you have 5 points, if you have 3 points in which we have 1 point at the top and the other point at the bottom, we can say it's our line of best fit. So that's our table, T square against M. You can see me writing it on the board. Okay, so and we have our M to be 150 to 350. Alright, so having done that, want to draw a line of best fit. As I said, you need to ensure that it is actually dividing your points into about equal size. So you can see me trying to draw it, the line of best fit. Okay, so after drawing that, we are also told, okay, you can see it also has an intercept. So we are going to be looking at what our intercept is on the vertical axis. I think that's about 0.09. So you can see I was explaining that you have one at the top and the other one at the bottom. That means the line is passing through the points such that, okay, so that's our intercept. We have it to be 0.09 second square because it's on the T square axis, so you need to put that. Okay, so we also said our K is what? 4 pi square over S. Don't forget that this our S is the slope. So I was about doing this, if I remember that I've not done I've not drawn the slope. So here I'm drawing the slope here. Okay, so I'm drawing the slope here. I'm trying to extend the slope so that it doesn't actually stop on that last point. Our triangle of slope should be pretty big. It should be at least 2/3 of our graph. Should not be too small. Okay, so that's our slope. I've drawn the slope. So we want to calculate the slope now. Our slope is T square X square. T2 square minus T1 square over M2 minus M1. So when you look at the values from that graph, we have it to be Okay, I'm going to be writing it on the board. Minus, okay, what's our L? L falls on 0.05, okay, divided by, we have 450 minus 75. Okay, so that's our slope. So by the time you get your slope, you're going to be substituting it into the formula. K is equals to 4 pi square over s. So from here you can get the mass of the meter row, and also do the other ones. I wish you best of luck. Bye.